I hinted at this in 2 videos ago. I was talking about determining whether or not the sign on the spring constant, I'm sorry, the sign on Hooke's law is positive or negative. And so I kind of walked you through with forces on that. Here now we can actually use this thing I said, energy. And energy is, it just describes how much ability you have to go or to move or to do something based on either spring potential, so a spring can make me go, chemical reactions can make me go, what else, height. If I go up high, I have this potential energy that if I jump off that height safely into the water below, then I gain energy, I gain velocity. And so that's all we're talking about with energy, is that we have two different types. We have kinetic energy, so kinetic, and this is related to motion. And then the other one I have is this potential energy. So this is from my spring. I can have a spring, and I have more than what I'm going to list here. A spring I can have from height. I can have chemical, I can have thermal. There's all sorts of different types of potential energies. The ones that we're going to focus on here are based on position. The energy I can gain or lose based on a position. So mathematically, I can define these in terms of motion. Let's see, we had momentum. We talked about that. If I want to get things into this thing, it's joules. Let's see if we can't kind of see where this comes from. Because remember joule from work, let's see, we said that's a force times a distance. I'm sorry, times a displacement. And a force, so I have, let's see, kilograms, meters per second squared times meters. And I kind of played around with that. At one point I went kilograms, let's see, meters per second, doesn't this look like velocity squared? Indeed. So we have that, we have the mass. The only thing we're missing in front of this is this factor of 1/2. Now we can see this graphically where that 1/2 comes from. And if you don't immediately like kind of rationalize this in your head to where you're comfortable using it, don't feel bad. They spent quite a lot of time hashing out that term. In fact, for quite a while, energy was defined in terms of mass velocity squared. When I tell people to think about and just kind of get your brain wrapped around why that 1/2 is that we never start like instantly at some given velocity, right? You have to start at 0. We haven't figured out how to beam ourselves up and be in a split second, not a split second, instantly. So starting at time 0, I go from rest to 1,000 miles an hour. Can't do that. Can't do that. I have to build up to that velocity. I can get there faster and slower depending on how I'm doing it, but I have to build up to it. So that is a way to think about how that 1/2 comes in from, is that there's this average amount that I have going into the energy I possess at a given velocity. All right, so we have that. And then from position, well, I'm kind of hinted at that. So here is my safe water below. I'm up here. After I've made my jump, I'll have kinetic energy. And that kinetic energy is going to increase until I get to the water. At that point, it's at a maximum. Up here, then what I call that energy is potential. I have the potential of converting that height into motion. So this one here is related strictly to my mass times gravity times height. Why did I do that? What is that? Isn't that just the force due to gravity? And that's the displacement straight up. So this is the potential energy for height. The force due to gravity moved some amount up. Now, an important thing to keep in mind is that this is true for any relative height. So it doesn't matter if I'm this high and then like 2 inches over is this another big chasm happening down below. So like this would be 20 meters into some body of water, and then below that, so this is some canyon up in the mountain or something like that, and then I find out that this is actually 5,000 meters in elevation. Probably not realistic, but that's okay. I'm not worried about the potential height from my total height. I'm comparing this height here, which I would just call 0, to this height here, which would be the 20. So it is this comparison of height difference here. Doesn't matter what's going on above, doesn't matter what's going on below. We're just comparing those 2 points. That's potential energy relative to height. Then the other one we just did on the other video was from a spring. So remember, that's not a constant force. So that one takes on this. It looks very similar to this 1/2 mv squared, but don't confuse them. This stores or takes out. So this is losing oomph going up until I stop, like a roller coaster, which will be one of our examples. Or I am letting the spring, no, that would be the wrong way. I'm compressing the spring. I'm losing oomph, compressing the spring. Okay, so I store energy in that spring, or I can release energy from that spring. This thing is what will make me go or make me stop. How's that? Get out from underneath my